So let's do a little review of the slope formula. In high school, you spent tons of time finding the slope of linear functions, right? That's because a linear function, the defining characteristic of a linear function is the slope is constant. All right, so here's the slope formula. This one in the middle is probably what your high school teacher wrote, right? I started using delta y over delta x, meaning change in y over change in x. And just the other day, I started using this notation over on the right. Okay, and hopefully that didn't confuse you. This is simply another way of writing the slope function or slope formula. So this one is saying if you have points A and B are your x values. So on the bottom, I have my change in x. And then if I have some function f, then when I do f of b minus f of a, right, here's f of b over here, this y value. Here's f of a over at this point, right, where this dotted line comes across, right? When I do f of b minus f of a, that's my change in y. So notice that the slope formula requires 2 points. And the slope formula lets me find the slope of a straight line. Now, what happens when I go to a curve, right? And the whole reason that you are going to take calculus is because you have to learn how to find slope of functions that are not linear. And so we're going to start this process here in pre-calc, and you'll pick up with this when you get to Calc 1. So how are we supposed to find the slope of a curve when, as I move along this curve, the slope changes continuously? Okay, like right here, we have a much steeper slope than we have down here where the curve is much flatter. All right, as I move along this curve, the slope changes. And the other problem I'm having is all of my slope formulas require 2 points. What if I only have 1 point? All right, and so we started doing this the other day when we were estimating velocity. We said, okay, I have to have 2 points, right? So I can get a very good approximation of the slope if I pick a point that's very close to this point 416, right? I want to know what's happening right at this instant of 4, but as long as I pick 2 points that are very close together, then I am going to get a pretty accurate representation of what is actually happening right at 4. So what is a point close to 4, right? And I could be close on either side. I could say, well, I'm going to pick 3.9, or I'm going to pick 4.1. Now, is 4.1 close to 4? You know, as we said in the last segment, that's a, close to is a very relative term. So I could pick something like, for my second point, 4.001. Okay, and therefore my functional value then, all right, so my curve is y equals x squared. So I'm going to square, excuse me, I'm going to square 4.001, and the y value that I get, and I want to take all of the decimal places that I get, is 16 point, let's see, I've got 2 zeros and then an 8. Oh, that's a 0. Sorry, 2 zeros, then an 8. Oh, my cursor is sticking. That happens sometimes, and I don't know why. So I'm having trouble writing. And then an 8, and then a 0, 0, 1. Okay, good luck reading what I just wrote. That was 2 zeros here. 0, 0. Okay, so if I want to find the slope at that point, and I'm really finding the slope of a straight line, right? The line that connects these 2 points, okay? But because this point is very close, this will be a very good representation of what the slope actually is at the point x equals 4. So let's see, change in y, right? What are my y values when I subtract them? I would be left with just the decimal portion. And then when I subtract these two x values, I would be left with just the decimal portion. And then I don't even need my calculator because I move 1, 2, 3, 1, 2, 3, and I get a slope of 8.001. Okay, and so that is my estimated slope at the point x equals 4. Now, the closer I get to 4, the better my estimation is for the slope right at the point 4. So who could get closer to 4? Right? And somebody would raise their hand and say, well, add an extra 0. All right, I have 3 zeros. Now who can do better? Somebody else would say, put 4 zeros in. Right? Who can do better than that? Well, put in 5 zeros, right? And I could play this game for a very, very long time where I just kept getting closer and closer to 4. And so here's how we solve that problem. We say, okay, let's get really, really, really close to 4, right? So let me call this value of x 4 plus h, right? The x coordinate of the point that I want to pick, and then I'll just recognize that h is some really, 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 really small number, right? Where I put a whole bunch of zeros here, like 30 zeros, and then a 1. Okay, so I don't want to write 4 point and then 30 zeros and then a 1. So I'm just going to call my second point 4 plus h. Okay, and then my y value would be f of 4 plus h. So let me draw a new picture. Okay, so here's my curve. I've got the point 4, 16. Okay, that's my 1 point. And then my second point is 4 plus h, where I know that h is some really, 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 really small value. Like that, okay? And so then I have to find f of 4 plus h. Okay, well, what is f of 4 plus h? Remember that my function is x squared. Okay, so that means that I have to square 4 plus h. Okay, so then when I do that, I get, so I need to square this. It's so tempting to think that I could just square the 4 and square the h, right? But remember that this means 4 plus h times 4 plus h, and I have to FOIL. So I end up getting 16 plus 8h plus h squared. All right, so that is what I get for f of 4 plus h. So then I have to subtract these two, right? Because this one's f of 4, which is 16. Right, so f of 4 is 16. F of 4 plus h is this expression over here. All right, so my slope is f of 4 plus h minus f of 4. Okay, and then I'll put in the values that we've computed in a minute. All of that over, and then the difference in x values, because this is the change in y, right? I'm subtracting my y values. This is the change at x. Okay, so I get here. All right, so the 4's cancel, I just get h. And then this is going to be kind of convenient because when I plug in f of 4 plus h, is this expression the 16 plus the 8h plus the h squared minus f of 4. So f of 4 is just 16. Okay, so look what happens. These are gone. And so then I get my slope is, now look, I have 8h plus h squared divided by h. So I am allowed to divide by h as long as I go into each term of the sum. All right, because I have a sum here, not a product. So I have to go into each term. So I get this, 8 plus h, that's my slope. And remember what I said about h. H is a really small number. I said h was 0 point, and then I had like 30 zeros and then a 1. And then I said, well, that's so small. I don't really care about 30 zeros and a 1. Do I really have to say the slope is 8 point and then 30 zeros and a 1? I want to just say the slope is 8. Okay, and so this should remind you again of our conversation about limits, where I say I don't want to call the answer 8.30 zeros and then a 1. I want to just call the answer 8 because that's close enough. All right, so what eventually I'm going to do when I want to find the slope and I decide to use h, right? I decide to add h to that x value to create a second point. What I'm going to do is I'm going to come along here and say, all right, to find the slope, I'm going to do all this, but then I'm going to take the limit as h approaches 0, because h can't be 0, right? Because if h is 0, then I have the exact same point twice, right? And that's, that doesn't work, right? So h can't be 0. But h is so close to 0 that by the time I get to the end here, I want to just say, I'm going to plug in 0 for h, right? And let me just call this slope 8. All right, and so therefore, this limit then is 8. And I am going to say the slope at that point is 8.